about to begin our review video for section 4.9. That's chapter 4, section 9. And as always, we start with the learning targets. And the learning target for today is to solve problems by involving similar triangles. So we're going to use the relationships of proportionalities in similar triangles to solve for missing information. Here's a vocabulary word. Indirect measurement is a technique using proportions to find measurements. And many times that's what you find when you're using similar triangles. So here's one. A real life problem. A tree in front of Marcel's house has a shadow that is 12 feet long. 12 feet long. Marcel's shadow is 3 feet long. If Marcel is 5.5 feet tall, how tall is the tree? Well, we've got a triangle. We've got two similar triangles here. This side, the height of our tree is unknown. The base of the tree is 12, the base of the shadow is 12 feet. Marcel is 5.5 feet, 5.5, and his shadow is 3 feet long. So let's set up a proportion here where we're going to say 3 is to 12 as 5.5 is to the height of the tree. Those two proportions, since this is a similar triangle, those two proportions must be the same. As I look at this, I want to solve for the missing x. I'm going to choose to cross multiply. And fine, so I've got solve that then. 3x is equal to 12 times 5.5. 3x then is equal to 12 times 5.5. And I'm going to do that on my calculator. And let's clear. 66 feet. So 66 is equal to 3x. I'm going to divide both sides by 3. And I'm going to get x is equal to 22 feet, which is the height of the tree. So the height is 22. The height of the tree is 22 feet tall. Very similar problem here, but do this one on your own, and then come back and check the video to see if you're correct. This one we're asked to find the height of the individual when the flagpole is 20 feet tall and its shadow is 40 feet long, and the shadow of the individual is 10, and we want to know the height of the individual. So I'm going to say, well, 20 feet is to 40 feet as x feet, the height of our individual, over 10 feet. If I work on cross multiplying this again, 20 times 10 is 200, and that's going to be equal to 40 times x. Solving, dividing both sides by 40, x then is equal to 200 divided by 40, or 20 divided by 4, which is 5. So our individual is 5 feet tall. Two triangles shown in the figure are similar. Find the distance d across this stream. So we're looking for this distance. We know the triangles are similar, so we can set up our ratios and say 60 meters, sorry, is to 20 meters, as 48 meters is to distance d. All right, I'm going to do some cross multiplying on this one. So I've got 60d, 60 times d is equal to 20 times 48. 20 times 48, I'm going to divide both sides by 60. I'm left with d then is equal to 20 times 48 divided by 60. I think I can do some simplification first. I can take 20 and divide it into there, and 20 and divide it in there and get 3. So I'm going to get 48 over 3 is my distance d. And if I reduce that, 3 will go into 48. I think I get 16 feet. So d is equal to 16 feet. very similar problem, but do this one on your own and then come back and check the video to see if you're correct. All right, we're going to say our ratio here, we're looking for D feet across the river. We're going to say that's 5 feet is to D feet, our unknown, as 20 feet is to 28 feet. Well, I'm going to cross multiply again. 20 times D is equal to 5 times 28. 20 times D is equal to 5 times 28. 140. Divide both sides by 20. And D is going to come out to be 7 feet. 7 feet across the stream. Thank you.